I'm developing optical nanosensors based on fluorescent nanoparticles, meaning nanoparticles that emit light. Using smart functionalization, these nanoparticles can identify and bind a molecular target of interest, resulting in a modulation of the emitted light. This technology can be used to detect and monitor important biomarkers and can potentially be used for diagnostic purposes or to assess a treatment strategy. I envision to utilize my nanotube sensors to probe complex biological systems at the nanoscale, to shed light on the molecular processes that take place at the heart of biological function. It can help us understand the natural world better, and in turn can also have impact on human health and well-being.
I am an engineer interested in understanding the brain. Our brains contain billions of neurons connected by tiny synapses through which they communicate. Severe neurological disorders such as epilepsy and autism often arise due to dysfunction in synapses. At the moment, there is no cure for such disorders. In my lab, we develop and apply microscopy technology to observe synaptic structure and function throughout the brains of larval zebrafish. These small vertebrates have neurons and synapses similar to ours, but they are transparent, and thus, amazingly, we can look at their active brains non-invasively while they freely swim in a dish. Our goal is to figure out how nanoscale structures in these brains give rise to brain activity and behavior, what goes wrong when a particular synaptic component malfunctions, and what can be done to fix this, not in the fish, but in humans, of course.
I'm an experimental physicist, and I'm interested in the interaction of light with topological materials. For example, topological insulators, which are insulators. They can't conduct current on the inside, but are conducting on the edge. These materials have a lot of potential for use as a basis for quantum computers or as detectors for IR light and even as dark matter detectors. A really fascinating aspect for me is how to control some properties of these materials by shining light on them. I'm using lasers that generate very short pulses of light, and I photograph movies of how the electrons in these materials react to the light. My vision is to explore the different ways light interacts with topological materials, both in order to understand these materials better and to harness them for quantum computation.
My lab studies the way by which cells in our brain communicate with each other. We now know so much about the human brain from decades of studies. We can, for example, map which cells are communicating with each other and what would be the input and output of these communications. But we still do not really understand the mechanisms by which these components work to maintain healthy brain activity. My lab studies these questions through the use of cryo-electron microscopy. We use the microscope to visualize in 3D protein receptors in the brain that, when they malfunction, are responsible for the development of ADHD and schizophrenia. And our vision is to find a way to fixing them when they do not function properly. My personal message on advancing women in STEM in academia is to follow your heart. Find a scientific field you feel most passionate about and don't be afraid to go for it. There might be many challenges along the way, but if you have your true passion, nothing else would matter.